Hello, Professor. My team members are Krishna, Shashi, and Divya. My topic about real-time face detection and recognition. So the project mainly focus on the implementing on face recognition system using PyTouch and popular deep learning framework. Learning about pre-training model, approaching the involving the fine tunnels and binary classification is on a data set. The object of developing a robot and accuracy face recognition model capable of between the individual of the adapt model to interact the given task involving the data processing and modeling modification through the evolution. So topic about the main project objective accuracy and real-time face detection in the video stream. So recognition on individual based on the facial features. Statement of value. So improving and offering and reducing. Improving the real-time face recognition, offering some seamless and personalized using the experience, reducing the need for the physical access control. So state of law, like we are using different type of the stages. So object detection and also designing the face detection and facial landmark location using the real-time face detection application. And another stage like detecting the uh, high accuracy and the efficiency. Relevant data. We are some of relevant data using the previous object detection models. So by we are approaching the uh, facial recognition, deep learning model, and also convolution neural network and label data set of facial training and testing, and open source tools like OpenCV for the image processing. So, real-time face detection and recognizing system, detailing technical document and using the guides, summarizing the projects and the methodology and result, presenting the summarizing project outcomes and application. So evaluation methods, accuracy of the data detection and recognition and processing for the real-time data detection, user satisfaction and feedback, and comparing the analysis exiting the face recognition system. So here the some of the reference using the previous one we are testing the new thing. Thank you.
Hello everyone. Here I want to explain the code. You like face recognition using PyTorch code. Here we are importing essential libraries for image processing and deep learning tasks. It includes modules for file operations, image processing, downloading files, plotting, and numerical operations, and also deep learning functionalities provided by PyTorch and Torch Vision. Additionally, it imports components for neural network modeling, optimization, and data handling utilities from PyTorch. Here, we download a file from Google Drive with the specified file ID given in the URL and saves it with the name annotated RGB images in the current directory. Here, when it comes to the dataset properties, we compute and prints various properties of the images, including their formats, number, average dimensions, color modes, channels, and aspect ratios. And it also provides a quick summary of essential statistics about the dataset, facilitating a better understanding of its characteristics like image formats, number of images in the average image dimensions, color modes, image channels, average aspect ratios. Here we it is a function to display random images to load and display a specified number of random images from the added RGB directory folder. The images are resized to specified target size for uniform presentation, and finally it calls function to display 10 random images, and the 10 random images are what and are you can see here. And when it comes to this custom data class, we are defining a custom face dataset, and it is created with the specified image folder and transform a custom faces for face images. The dataset includes a basic label assignment based on whether the image file name starts with group or not. The data loading pipeline involves opening images using the PIL library, applying specified transformations, resizing, random and horizontal flip, conversion to tensor and normalization, and returning to the image and label in the getting item method. And here it is optimization looping just for the first mini batch. Here we are the partitioning the data set and the core partitions the custom dataset into training, validation, and test sets using the random split function from PyTorch library. The split is based on 80% for testing and 10% for validation and 10% for testing. And after training, we can see the 161 samples for training and 20 samples for validation and 21 samples for test set. And here in here we are doing normalization augmentation. And next we are visualizing first sample of each mini batch of size 8. You can see the 8 mini batch size of for a group, and here we are optimizing as again for the first mini batch. Then we are calculating the loss for the first mini batch. And when it comes to data pre-processing, the dataset underwent pre-processing to ensure compatibility with the model, image resizing, random horizontal flipping for augmentation, conversion to tensors, and pixel normalization were applied. And the second, here the detailed summary of the modified model, including layers, output shapes, and parameters, were provided to offer insights into model's complexity. We can see the labels like layer, output shape, parameters, and everything. When it comes to fine tune the network of the network for the data set, the model was fine tuned using mean square error at the loss function and stochastic gradient descent as the optimizer. The training loop spanned 10 approaches with updates to minimize the MSE loss. You can see the each approach and the training loss here. And finally, we can see the validation accuracy. It is like we can get 100% accuracy. And we are testing on the test test model. Here after testing, we can get the accuracy 100%. And here the achieved results showcase the effectiveness of the fine tuning process on the facial recognition model for the binary classification task. The model was designed to distinguish between the two classes into the annotated images dataset with a focus on the optimizing accuracy and minimizing the loss. And when it comes to conclusion, the implementation of face recognition using PyTorch and fine-tuning the model has yielded remarkable results. The progressive decrease in the training loss over 10 approaches attests to the model's effectiveness, learning, and parameter adjusting, indicating its aptitude for discerning facial features. The validation and test accuracy achieving 100% reflect the model robust generalization to previous unseen facial data. And with over 11 million parameters, the model harnesses its complexity adeptly, making it a potent tool for real-world face recognition tasks where precise and reliable identification is crucial. Thank you.